So today we're going to talk about the use of interrupts in operating systems. The OS is responsible for coordinating all activities within a computer. It makes extensive use of interrupts to perform I/O operations and communicate with and control the execution of user programs. The interrupt mechanism enables the OS to assign priorities, switch from one user program to another, and implement security and protection features and coordinate I/O activities. The OS incorporates the interrupt service routines for all devices connected to a computer. When an application program needs an input or an output operation, it points to the data to be transferred and asks the OS to perform the operation. The OS suspends the execution for that program temporarily and performs the requested I/O operation. When the operation is completed, the OS.
An operating system provides a variety of services to application programs to facilitate the implementation of these services. Most processors have several different software interrupt instructions, each with its own interrupt vector. In a computer that has both a supervisor and a user mode, the processor switches its operation to supervisor mode at the time it accepts an interrupt request. It does so by setting a bit in the processor status register after saving the old contents of the register on the stack. Thus, when an application program calls the OS by a software interrupt instruction, the processor automatically switches to supervisor mode, giving the OS complete access to the computer's resources. When the OS executes a return interrupt instruction, the processor's status to the application program is restored from the stack. As the result, the processor switches back to the user mode.
Transfers controlled back and forth using software interrupt. To illustrate the interaction between the application programs and the operating system, let us consider an example that involves multitasking. So multitasking is a mode of operation in which a processor executes several user programs at the same time. Time slicing is a common OS technique that makes this possible. With this technique, each program runs for a short period called time slice. Then another program runs for its time slice and so on. The period is determined by a continuous running hardware clock, which generates a program together with any information that describes its current state of execution is regarded by the OS as an entity called a process. A process can be one of three states: running, runnable, or blocked. The running state means that the program is currently being executed. The process is runnable if the program is ready for execution but is waiting to be selected by the scheduler. And the third state is the block, which means the program is not ready to resume execution for some reason. OS initialization, services, and scheduler. It describes the routines needed to implement some of the essential functions in a multitasking environment. At the time the operating system is started, initialization routine is executed. It set interrupt vectors, scheduler for time slice clock, OS services for software interrupt, and I/O data for keyboard interrupts. OS services is a routine which examines stack to determine requested operation. It also called appropriate routine. While the scheduler save program state, select a runnable process, restore saved context of new process, push new values for PS and PC on stock, and return from interrupt every second. I/O routines. When an I/O operation is in progress, the program that requested it cannot continue execution. Hence, the I/O initialization set process status to block, initialize memory buffer address pointer and counter, call device driver to initialize device and enable interrupts in the device interface, return from subroutine. We use I/O data routine because there could be several devices connected to the same interrupt request line. I/O data begins using poll devices to determine source of interrupt, call appropriate driver, then set process status to runnable if n is equal to 1, then return from interrupt. We have assumed that the device driver for the keyboard consists of two routines.
The keyword initialization enables interrupts in the interface circuit by setting the appropriate bit in its control register. The keyboard data check device status. If ready, then transfer character. If character is a courage return, it will set to 1 a flag called end to inform I/O data that the requested I/O operation has been completed.